Hey there, this is the video tutorial for determining the type of chemical reaction that's occurring. We are going to be dealing with four main types of chemical reactions: synthesis, decomposition, single replacement, and double replacement. This graphic is very useful. Keep referring back to this throughout the assignment. It will guide you. What I want you thinking about with this graphic is whenever you see a letter like A or B, C, D, I want you to pretend that that's an element in your reaction. Whatever pattern you see happening in your reaction, that's the type of reaction that's occurring. For example, if I see that I have two elements that are joined and they split as a result of the reaction, I know I have a decomposition reaction. If I see that I have a pair and a free element to start, and I end up with a pair and a free element, but the free element swapped with one of the two in the pair, then I know it's a single replacement. So match up the pattern that you see in your chemical reaction with the real elements with what you see on this chart. I won't throw any curveballs. I'm only going to use these four main types of reactions. We will not talk about combustion or acid-base reactions yet, just these four main types. On this slide, you can see a few examples, starting with this potassium, chlorine, oxygen, which breaks down into potassium chloride and oxygen dioxide, actually. You can tell that this is a decomposition reaction because this larger group of elements is breaking apart into two smaller ones. Thus, it's decomposing. This is a decomposition reaction. Just like you see here, we've got a group that's breaking down into two smaller parts. Decomposition. Look at this second one. We've got zinc and then copper chloride. They react, and what comes out? Zinc chloride and a free copper. So my rationale for saying that this is a single replacement is that there's a free element which is swapping places with one of the two in the pair right here. That's the same as this pattern you see right here with single replacement. So I want you throughout the assignment looking back at this chart and just match the pattern with what you see with your elements with what you see on the chart. There are also some other helpful slides here. We went over these in class during week 23. This is just going to give you some real examples of each type of reaction with a graphic at the bottom to help you remember and a little explanation of what that reaction is. Most of you have this in your notes already. One way I like to remember the replacement reactions is to determine if it's a single or a double replacement reaction. Think about this. Does each dancer have a partner going into the reaction? In a double replacement, you're going to have one person from each partnership swapping places with one person in the other partnership. Whereas if you just have a single replacement, you're always going to have one free dancer who is stepping in and dancing with that other person's partner. So just a fun analogy to remember single versus double replacements. Okay, let's actually look at the assignment and go through one or two as an example. Let's start here. Okay, lead oxide turns into lead oxide with a free O2. So actually, look at this. We've got one thing here, which is turning into two different things. So for that, I know it matches up with, go back to my handy chart, matches up with decomposition because I've got one group which is turning into two groups. So on the assignment, I'm going to write decomposition. It's not typing. There. Oh. And the last part is going to ask you to explain why you think it's a decomposition reaction. So I would write down here that I see one group breaking apart into two separate groups, and that's how I know it's a decomposition reaction. Let's look at the next one. Aluminum with hydrogen chloride turns into aluminum chloride and free hydrogen. So let's look back at this. when you compare it to this chart, the reaction that I'm seeing is looking a lot like this third one here, because it is going from hydrogen chloride with, let me check what that was. Yep, we have hydrogen and chlorine here, hydrogen chloride, and a free aluminum. And it turns into aluminum chloride with a free hydrogen. So that's why I know that this is going to be a single replacement reaction. So I would write that here. And I would explain that this is a single replacement reaction because there is a free element that is taking the place of one of the two in this partnership here. So that's how you determine the reaction type. Use that chart, refer back to that, look for the patterns and match it up with the diagram